So if I wrote it as separate radicals, I would have the 5th root of 3 over the 5th root of 4y. Correct?
Mm-hmm.
Can I take this exponent of 1 and divide it by that 5? Nope. Can I take this exponent of 1 and divide it by this index of 5? Nope. Can I take this exponent of 1 and divide it by this exponent of 5? No. But now I have a problem of, I've got a radical left in my denominator, don't I? I need to get rid of it. So I'm going to have to multiply both the numerator and denominator by the 5th root of something. The 5th root of something. So I start looking, and keep this as simple as possible. If I was to take this index into an exponent here, what would the smallest exponent have to be in order to get me a division? Well, if this index is 5, wouldn't the smallest one have to be 5 here? Does that make sense? Well, if this exponent is 1 right now, what exponent on the 4 would I need out here to get this up to a 5? 4 to the 4th. Why did I pick 4? Because doesn't 4 plus this 1 give me a 4 to the 5th? Which is divided by 5 then? Evenly? 5 can be divided by 5 and give me an even exponent, right? Okay, this exponent is 1. This index is 5. So what power of y over here am I going to have to put in to get me up to a 5? Y to the 4th. So up here I have 4 to the 4th, y to the 4th. Because I have to do the same on both numerator and denominator. Okay? Alex, you're giving it a strange look of, what the?
What? No, I'm not.
Okay. We ready to go on? So right now, I have the 5th root of 3 times 4 to the 4th y to the 4th. Do you understand how I got that? Or not? All I did is, since these two are the same index, I take all of this radical times all of this radical. So here's the 3, here's the 4 to the 4th, here's y to the 4th. I'm still going to have to do something here. But right now that's just the multiplication, isn't it? Over the 5th root of 4 to what power? To what power? Because 4 to the 1st times 4 to the 4th gives me 4 to the 5th, doesn't it?
How did you get that 4 to the 5th?
4 plus 1.
Oh, yes.
Right? What's the exponent on the y now? Same idea. The exponent here is a 1. The exponent here is a 4. When I multiply, I add exponents, right?
Yep.
Why did I say I'm going to have to do something here? If I leave it this way, I could rewrite the 4 as 2 to the 8th. How do I know that it's 2 to the 8th? Well, if I have 4 to the 4th, isn't that the same as 2 times 2 to the 4th? Which is 2 to the 2nd to the 4th, which is the same as to the 8th? Because here I have an exponent to an exponent. Can't I just multiply those exponents? Right? Times y to the 4th over, well, can't I take this 5 divided by this 5? Well, what's 5 divided by 5? So I have 4 to the 1st. Can't I take this exponent of 5 and divide it by that 5? Which gives me an exponent of 1. Hey, we're getting closer. You see any other simplifications that I can do? Or not? Mrs. Cronin's saying yes. How about the rest of you? Yeah. This to the 8, since this 8 is bigger than this 5, can't I take 5 into this 8? To the 1st, right? The 5th root of 3 times 2 to the 3rd times y to the 4th over 4y.
Why is it 2 to the 3rd?
How many?
Yeah.
8 divided by 5 is 1, with 3 left over. Do you see why it's a little bit important to understand your multiplication and division properties of simple numbers? You can do it on the calculator. Do you know how much longer it's going to take you to do it?
So, Mr. Horman, would you take that 2 to the 3rd and make it an 8, or do you leave it?
Yeah, I would.
You will?
Yep. What's 2 to the 3rd? 2 times 2 is?
4.
Times 2. I'd say times 3. 24. So to finish simplifying this, I would have 2, the 5th root of 24, y to the 4th, over 4y. Right? So I went from here to here because this 2 to the 3rd was an 8. 8 times 3 is 24. I'm not done. You're going, oh my God, is this going to go on forever? No. This is a whole number 2. This is a whole number 4. Can't I reduce this 2 and this 4 by 2?
Yes.
2 can be reduced by 2. 2 can be into 4 goes twice. So I end up with
1.
the 5th root of 24 y to the 4th all over 2y.
So 2 cancels out?
This 2? Or were you talking this 2?
Yeah.
Isn't a common factor between these two 2?
Yep.
2 goes into 2 once. 2 will go into 4 twice.
Yes.
Yep. So yes, it cancels out. Guess what? I'm done with that problem. Okay? Next problem. Square root of 98 minus 2 the square root of 32. Everything we've done with so far has had adding or subtracting in between multiplication or division, right? Now I got a subtraction. So work with this one, simplify it. Work with this one, simplify it. 98, can it be prime factored? For those of you that don't remember your division properties, can't 98 be divided by 2 because it's an even number? 2 times 49. Are there any 2 factors of 49? 7 and 7. So right now I'd have 2 times 7 squared, right? Minus 32. 4 times 8. 4 is 2 times 2, isn't it? 8 is 2 times 2 times 2. Or if you need to take the step, 8 is the same as 4 times 2. Well, 4 is already a 2 times 2, isn't it? So that's where I got 2 times 2 times 2. So this becomes 2 to the 5th power. So now I can erase this so it doesn't clutter up things, and I can erase this. Can I simplify this radical? Has an implied index of 2. This one has an implied index of 2.
Yes, 7 on the outside.
7 on the outside. The square root of 2. Minus. Right? Where she got that was, this 2's right here, isn't it? This 2 came right straight down from up here. This index of 2 will go into 5 twice, leaving me with 1 left over. So right now I have 7. The square root of 2 minus, what's 2 times 2? Now I'm not looking at this 2 times 2, I'm looking at this 2 times 2, because 2 squared is, take this 4 times this 2. So I have 8, the square root of 2. Now if I'm adding and subtracting, I have to look for similar terms, don't I? Right? You don't see any x's or y's or anything like that in here, do you? But the similar term comes from, is this radical have the same index and the same number inside the radical as what this one does? That means they are similar terms. And if I had 7 of them over here, and I'm subtracting 8 of them over here, so if I had 7 apples on my left-hand side, and somebody wanted to eat 8 apples, how many apples would I have? -1, the square root of 2, like so. But this and this become similar terms. Looking at the original numbers that are up here, would you ever think that they would be similar terms? They wouldn't be unless you went through and simplified it. Okay? Long lecture. Lots of stuff. Questions on that?